Okay, so welcome back, and now we're going to do another example of dealing with a frustum. But it may not look like a frustum by the orientation of the picture. So let's read the problem, and then let's discuss it. Okay, so it says a connection must be made between two square vent openings in an air conditioning system. If the sheet metal used to make the connecting piece weighs 0.906 pounds per square foot, what is the total weight of the piece shown in the figure? All right, so we need to find the lateral surface area, right? Because again, based on this is the connecting piece between two openings. Notice that one of the openings is larger than the other opening. So this is the sheet metal vent that is going to connect the two vent openings, right? And so it's got to be tapered. So that's a different issue, but what do we need here? Well, this is one opening, this is the other opening. Notice that this is a frustum, right? If you tilt it this way, it's a frustum because we have got the bottom base, it's a pyramid with the top cut off, essentially. So we've got the bottom base, which is a 9 by 9 square, and we've got the top base, which is a 6 by 6 square, which means the slant height is this distance here, from here to here, okay? So again, orientation is important, okay? So it's the slant height is the distance from this edge to this edge with a perpendicular line. Okay, so now that we understand that, we want to know what the lateral surface area is. So it's this area plus the back area plus the bottom area. Okay? And again, we could calculate that, but again, we have the formula. Okay? And since we have the formula, we don't want to try to derive it individually, right? So now, what's the formula? Again, the lateral surface area formula is going to be what? 1/2 times the sum of the perimeters, P1 plus P2, times the slant height, S. So now, what's the perimeter of the top? Well, in this case, P1. So the perimeter of P1 over here, let's call this P1, is going to be 4 times 6, right? It's a square, so it's going to be 4 times 6. So P1 is going to be 24 inches. P2 is going to be 4 times 9, right? So the perimeter of the bottom here, if you will, is going to be 36 inches. And then what do we have? We have the slant height, which is 28 inches. And so what do we get? We get 14 times what? 60. Okay? And so that's going to equal 840 square inches of surface area, lateral surface area. Okay, now we're not done. Okay? Remember the goal. What do they want? They want to know what the total weight of the sheet metal is to make this connection. Well, now that we have the total surface area, the lateral surface area, not total, but lateral surface area, now we're going to use the fact that the sheet metal has a density, or not density, but has a weight per square inch, which is going to be 0.906 pounds per square inch. Okay, that's the weight. Okay, based on surface area. And so now guess what? We've got the surface area, we've got the pounds per square inch, so the weight per surface area. So now if we have 840 square inches, right? And we want to convert this to pounds, we want this weight, we're going to use this as our conversion factor, right? Okay, or we can change this into our unit ratio. So that's going to be what? It means that we're going to have 0.906 pounds for every square inch of surface area. And so now inches squared cancels with inches squared, and we're only left with pounds, which is exactly what we want. And so we just multiply across, and we're going to multiply the two. We're just going to get 1 on the bottom. And so what's 0.96, or excuse me, 0.906 times 840? And we're going to get approximately 5.285. Okay, which if we round to 5.3. Okay, 5.3 pounds. Okay, there you have it. Have a great day.